Hey everyone, it's Mr. Han here. Here are our notes on how to solve systems of equations using equal value method. So before we get into our notes, or the first thing I want to do as we get into our notes is to answer the question, what is a system of equations? So if we want to be able to solve a system, we need to know what it is. So a system of equations, well, first we're just going to break down the word system, right? And a system is when multiple parts, like more than one thing, a set of things working together. Okay, so a system of equations is when we have two or more equations. So I'm going to write a complete sentence. A system of equations is when you have two or more equations. And so I can give you a couple examples of different systems, right? We have an ecosystem where we have trees, or depends on what kind of ecosystem you're looking at, but trees, animals, and they all kind of work together to create this environment, right? Our solar system is one that I use in our classroom, right? We have the stars, we have the sun, we have the moon, we have the planets, and all of those things work together in our solar system to kind of create what it is. It's more than one planet. There's a total of 8 of them. So a system of equations is when we have two or more equations working together. So when we ask you to solve a system, it's basically saying, all right, we have 2 lines or 2 equations. And so what is the meaning of a solution when I say to solve a system of equation which is when you have 2 or more equations? There are 2 things. The meaning of the solution is, number 1, the ordered pair that makes both equations true. So that's also going to be called the POI. So a POI. Okay? And so that's where the 2 lines, when graphed, will cross each other. And that's going to be that ordered pair that makes both equations true. So these 2 things are the same thing. The ordered pair will be your POI. Okay? Now, let's go ahead and try to solve a system, okay? So where would these 2 lines cross each other? Y equals 3x plus 18, y equals negative x minus 2. Now, we can go ahead and graph this, okay? And we can find that our m is 3, and our b here is 13. Same thing here, m equals negative 1, and b here is negative 2. And I could sit here and graph this, right? But I'm not going to. Okay, I just want you to know that it is a possibility to graph it. Okay, but really what I'm going to do is I'm going to use something called the equal value method. Okay, so let's take a close look at this, right? We can see y equals 3x plus 18, and here y equals negative x minus 2. And so the concept here that I want you to walk away with is that if y is isolated on both equations, right? Y is isolated, y is by itself. Y is isolated, y is by itself. If y equals 3x plus 18 and y equals negative x minus 2, okay, that means that these 2 values right here, 3x plus 18 and negative x minus 2, when we have a system, right, the point that they're going to meet when we graph, okay, we can go ahead and make these 2 equal each other. So these are equal value. Equal value. So they're going to equal each other. Okay, so I'm going to draw little arrows to show you what I'm talking about. So I'm going to go ahead and put 3x plus 18 equals negative x minus 2. And you're going to notice that the y's are no longer there, okay? This is as if I replaced this y with this y. And so this and this equal each other. Okay, so the equal value method, we can make this equal that, basically substituting our y's. Okay, and so when I do that, I can go ahead and solve. And so I can solve for x. Now that there's just one variable, I could go ahead and say, all right, let's solve for x. And so I'm going to go ahead and add x on both sides. And I get 4x plus 18 equals negative 2. Now I have to get the units on the other side. So I'm going to subtract 18. 4x equals negative 20. Last step is divide by the coefficient, which is 4. X equals negative 5. All right. Now, I was able to solve for x when these two equal each other. Okay? So if we take a look back here, what is a system? A system of equations is when you have two or more equations. Okay? And to solve a system, you need to have an ordered pair, which means you need the x and the y. Okay? So far, I'm telling you right now, you have half of your answer. Okay? Half of your answer. So I'm going to go ahead and do this in purple over here. Our POI. Okay? And we have our x value. Our x value is negative 5. Okay? And now we need to go ahead and figure out what our y value is. So in order to do that, we're going to take our x value and plug it back in right here and right here, and we're going to solve for y. Okay? So I'm going to go ahead and do the first one. Y equals 3 times, instead of x, I'm putting negative 5 plus 18. Okay, so you can see right here, I took this equation right here, and instead of x, I put negative 5, so I'm plugging it in right there. So I'm going to be able to solve for y now. Y equals negative 15 plus 18. Y equals 3. Okay? So I solved for y for one of them. I need to make sure that it fits into both, because this is a this is a POI, so this point should work for both lines. So if I plug in 5, I'll do this one in green. Okay, so let's go ahead and grab a green pencil. Y equals negative, and instead of x, I'm going to put negative 5 minus 2. Hopefully you're able to see I copied this portion right here. But instead of x, I plugged in negative 5. Okay? And I'm going to go ahead and solve for y here. It should equal 3. Y equals, the opposite of negative 5 is positive 5. Minus 2, y equals 3. So this works. Okay? Check it. Y is negative 5, 3 for both this pink equation and this green equation. So that's the one point that it's going to be true on both lines, which is where we call the POI, if I were to graph it. Okay, let's go ahead and do another one. So here's another example, solve this system. All right, so we're going to use the equal value method. Remember, y and y are the same. I'm actually going to circle that. So we're going to make these equal values equal each other. So 2x plus 6 equals negative 4x plus 9. I'm going to solve for x. So I'm going to try to get x on one side. This is smaller, so I'm going to add 4x. Add 4x. 9 equals 6x plus 6. Get the units away from x, so I'm going to go ahead and subtract 6. 6x equals 3. Okay. Divide both sides by 6. X equals 3 over 6, or that can be reduced to 1/2. Oh, fun. So I solved for x. Okay. Now what I need to do is I need to take my first equation, y equals 2 times, and instead of x, I'm going to put 1/2. Okay. I'm going to go ahead and solve. Y equals 2 times 1/2. 1/2 of 2 is 1. Plus 6, so y equals 7. We'll go ahead and check with the second equation. So what I'm doing right now, just so you have an idea, is I'm taking this solution, 3/6, which is also 1/2, and I'm plugging it back in, right? I'm plugging it back in into both of these equations. Okay, so I just did the pink one, and I replaced the 1/2 for x. I got y equals 7. My next equation should equal 7. We are going to check right now. So I'm going to go ahead and do the second equation. Y equals -4 times 1/2. Plus 9. Y equals, change that to green. Oh. So y equals -4 times 1/2 is -2. Right, 1/2 of -4 is -2. Plus 9, y equals -2 plus 9 is 7. So I got 7 on both. That means that the point of intersection, or our POI, is going to be when x is 1/2 and y is 7. Make sure you plug it into both equations in your system, because we are trying to find the one point that's going to be true. And when we plug in 1/2 for x, both of them become 7, so that's going to be a point on both graphs. Okay? Okay. Let's go ahead and find this last one on this page. We have a couple more on the next page, okay? So, here we have two equations. Now, you're going to notice that they're a little bit different, okay? This second equation is not in what? It's called slope-intercept form, right? We need to get it into y equals mx plus b, meaning we get y isolated, y by itself, okay? So, I'm going to go ahead and get this equation in y equals mx plus b form. So I'm trying to get y by itself. I need to do everything I can to get y by itself. So the first thing I need to do is get rid of 2x. I'm going to add 2x. Get rid of that. So I have 2y equals 2x minus 4. Divide both sides by 2. And y equals x minus 2. So that's my equation. So this right here is y equals x minus 2. Okay? And so for this one, we can solve using the equal value method, or we can also graph. So I'm going to go ahead and graph this first. Okay? Which one's our x-axis and which one's our y-axis? Right? X is horizontal, y is vertical, right? Our y-axis. So we'll go ahead and scale it. 1, 2, 3, 4, -1, -2, -3, 1, 2, 3, 4, 5, 6, 7, 8, -1, -2, -3, -4. We'll go ahead and take my first graph. Do it in pink. What is my M? And what is my B? M equals 1, B equals 3. So for this pink line, I'm going to start at 3. I'm going to grow by 1. So go over 1, up 1, go over 1, go over 1, up 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 1. So we'll go ahead and graph that in pink. Okay, I have a straight line. I'm going to draw my arrows. This is y equals x plus 3. So I did my pink one right here, y equals x plus 3. I'll do my second graph. I'll do that in green. And that's technically right here. The same thing, right? I just got y by itself. So this is now in slope-intercept form right here. So my M equals 1 and B equals -2. We'll start this line in green at -1. I mean at -2. That's where I start. and it grows by over 1, up 1, right? Our m here is 1. So over 1, up 1. Wow. Over 1, up 1, over 1, up 1. This line's supposed to be in green, so I'll keep it green. And this line right here is y equals x minus 2. All right, so I drew my two graphs, and here we have a situation, right? The graph, they're never going to meet. They grow at the same rate, but they start at different places. It's kind of like talking about twins. When will two twins be the same age? I mean, be different ages? No, sorry, forget I said that. I'm not thinking. It's talking about not twins, but somebody that, like you and me, when are we going to be the same age, right? We grow at the same rate, but I started earlier than you, or at a different time. So here, we can see by graphing, right, that there's no solution. Another way I'm going to show you is using the equal value method. So I'm going to go ahead and make these two equal. X plus 3 equals x minus 2, because the y's are equal values, right? We'll go ahead and make them equal, and you're going to see that we have no solution. We subtract x, and 3 equals negative 2. So here we have no solution. All right? And you can see in the graph, there is no POI. These two lines are never going to meet. When this line moves over 1, it goes up 1. This line moves over 1, it goes up 1. So they're never going to meet. They're growing at the same rate. So if I ask you which line is steeper, right, hopefully you know neither. They're the same. Okay. So there's an example of a no solution. Let's keep going, okay? Here's a couple more. We're going to say y and y have equal values, so we're going to make these two equal each other. So let's go ahead and do that. Y and y are equal values, so we're going to go ahead and make these two equal each other. So 7x minus or plus 4 equals negative x plus 4. Okay. And now I'm going to solve for x, add x to both sides. 8x plus 4 equals 4, subtract 4. 8x equals 0, divide by sides by 8. Does anyone know what 0 divided by 8 is? Right? It's 0. 0 divided by anything is 0. So now that I know what x is, right, I know half the answer. I need to plug them back in for the x's. So I'll do the first one in pink. Y equals 7. Instead of x, I'm going to put 0. 7 times 0 plus 4. The other one is y equals negative 0 plus 4. This should be green. Okay, let's do the first, solve the first one first. Solve for y equals 7 times 0 is 0 plus 4. Y equals 4. This next one, y equals negative 0 times 0 plus 4, and y equals 4. So it works when x is 0, y is 4 for both of these equations, right? We checked one here and one here. So our POI is 0, 4. So now you're just practicing using this this thing called the equal value method. So here these two are equal to each other. Y and y are the same, right? We're trying to see when y is the same technically. And so we're going to make these two equal each other. So 3x minus 8 equals negative 9x minus 4. Get x on one side. Which one's smaller, negative 9x or 3x? I'm going to add 9x. So we get 12x minus 8 equals negative 4. Add 8 to both sides. 12x equals 4. Divide both sides by 12. X equals 4 over 12, or that's also 1/3. If you divide 4 by 4 and 12 by 4, you get 1 and 3. All right. Now that we know what x is, we're going to go ahead and plug it back in to both the equations to find out what our y value is. So let's go ahead and do the first one. I'm going to do that one in pink. Y equals 3 times 1/3 minus 8. And the second one's y equals, let me highlight this. Y equals negative 9 times 1/3 minus 4. Okay, so I copied them, I plugged in x. Let's focus on the first one first. First one first, great. Y equals 3 times 1/3, 3 times 1, where's my parentheses? One divided by 3, close parentheses, is 1. Right, so 1 minus 8, y equals negative 7. Right here, y equals, instead of 3, I'm going to do negative 9 times 1/3 is negative 3 minus 4, y equals negative 7. Used my calculator. That was very nice of my calculator. They're the same, so our POI, right, our x value is 1/3, our y value is 7. Whoo! All right, last one. Solve the system. Y equals 8, y equals 2x plus 5. My voice is kind of going out. Sorry if I sound very boring. But here, y and y are the same. So we're going to make these two equal each other. 8 equals 2x plus 5. We're going to get x on one side, which it already is. So we need to get rid of minus 5, minus 5. 3 equals 2x. Divide both sides by 2. And x equals 3 over 2, or 1.5. I'm going to keep it as 3 over 2. But just so you know, 3 over 2 is 1.5. Okay, so I'm going to plug this back in. There's nothing to plug in here. So technically the first one is y equals 8. Hopefully our y value is 8. Okay. And the second one, right? Hopefully it will be 8. Let's see. Green. Y equals 2 times 3 over 2 plus 5. Y equals 2 times 3 over 2 is 3 plus 5. Y equals 8. Good job. Saying good job to myself, but it works. So we have a POI. POI is when x is 3 over 2 and y is 8. All right. If you have any questions, make sure you ask, okay? Hopefully this was helpful for you and kind of give you more assurance and just practice, right? with solving systems with equal value method. Okay. All right.